I'm Janae, and I work for Learning Undefeated, which is a nonprofit organization that provides life-changing STEM experiences to students from underserved communities. We're here today in my kitchen to do a science experiment that you can do at home using fruits, vegetables, and all sorts of liquids you can find right around your house. Now, you may be familiar with the sour taste of a lemon, but have you ever really thought about why a lemon tastes sour? Lemons contain citric acid, which is a weak organic acid that's found in citrus fruits, such as lemons, limes, and oranges. Have you ever tasted baking soda? Baking soda is a base and tastes very bitter. Bases also often feel slippery or soapy. In this at-home science experiment, you will use red cabbage juice as a pH indicator to determine whether certain liquids from around the house are acids or bases. Red cabbage juice is usually a deep dark purple color, but it turns red when added to an acid and green when added to a base. pH is a scale that we use to measure acidity, and it ranges from 1 to 14. The lower the number, the more acidic the solution is. The higher the number, the more basic the solution is. Red cabbage juice is the best known edible pH indicator in your kitchen, but there are many other safe fruits, vegetables, and even flowers that change color in response to acids or bases. Some of the other items you can use include eggplant, beets, blueberries, cherries, onion, raspberry, grape juice, and even tomatoes. You can use the laboratory protocol, which you can find online at learningundefeated.org/at-home-science, to test some common household solutions to see if they're an acid or a base. So some of the household items that you can use for this experiment are as follows. If you don't have all of them, it's all right. We have a list of other items you can use on our website. So we have ammonia, vinegar, baking powder. Now you want the stuff in the can, not the stuff in the yellow box. We have Alka-Seltzer tablets. I have some lemon lime soda, Sprite. I have 1 lemon, and then I also have some sugar. Now, I already prepared my red cabbage juice solution, which is right here in this container. So in order to prepare this, what I did was I took half of a red cabbage, I sliced it up, put it in a pan with 3 cups of water and boiled for about 20 minutes, which made the house smell fantastic. And then I strained out the cabbage and refrigerated the juice. So that's step 1 in your laboratory protocol. Now, in order to prepare all of our solutions, we're going to follow the steps that are in our laboratory protocol. So first, we're going to prepare a sugar solution, which is dissolve 2 tablespoons of sugar in a 1/4 cup of water. So we will do that first. Okay, while that is dissolving, we will pour in some ammonia into our ammonia cup. Now, in an ideal world, I would like to have clear ammonia, but you know, things are strange, so you have what you have. So right now I have yellow ammonia. I have lemon lime soda, which I'll pour in here. And for each of these, you want about a 1/4 cup. Delicious. Okay, now for the lemon juice, I'm going to juice a lemon. If you have lemon juice in your refrigerator in a little bottle, that'd be fine too. You don't have to be too concerned about getting seeds in there. It's totally fine. I did put, as you see, I put some paper underneath all of my samples because it does get a little bit messy and the cabbage juice might stain, probably will stain. So it'd be a good idea to have those under there. Okay, so made a big mess of my lemon juice, which, you know, science is messy. That's cool. All right. So for the baking powder solution, we're going to dissolve 2 tablespoons of baking powder into a 1/4 cup of water. So pretty much the exact same ratio as we did with the sugar solution. Okay, there we go. All right. And I'll have to give that a stir in a minute. And then last but not least, we have vinegar. So similar to the ammonia, I would have loved to have had clear vinegar, but you know, you're doing science at home, you work with what you have. So I have a little bit of apple cider vinegar, which for this experiment is totally fine. So this would be a good time to pause and ask yourself, just by your own observations, which of these solutions do you think is acidic and which is basic? So we already talked about lemon juice, so I gave you the answer to that one. Lemon juice is an acid, so hopefully that should turn red, which is our acid indicator. But some of these other items, what do you think they might be? All right, so we're going to go down the line and add about 1/4 cup to each of our solutions, and then we're going to make observations about whether the solution is an acid or a base. So we're starting first with our sugar solution, which is a purple in color. Next, we're going with ammonia. Now, I have yellow ammonia, and typically when you would mix something yellow with something purple, you would get brown. So let's see what happens here. Ooh, a nice green. I like that one. Okay, so we have an Alka-Seltzer tablet, which has not yet been dissolved. So we're gonna allow the red cabbage juice to dissolve that and see what happens. We'll come back to that one. All right, so we have our lemon lime soda. Good. We have our lemon juice. Ooh, which is a pretty red. We have our baking powder, which is a pretty radical blue, actually. All right, and last we have vinegar. So again, just like the ammonia, it's a little bit yellow. Typically you'd get brown when you'd mix something purple and yellow. So let's see what we get. Ooh, red. Nice. Congratulations. Now that you've completed all the steps in your laboratory protocol, it's time to evaluate your results. So we have our 7 solutions here. The first is we have sugar solution, which has stayed the same pretty much purple color as the red cabbage solution, which is telling us that your sugar solution actually is pH neutral. We have ammonia, which turned this crazy green, which is telling you that ammonia is a very strong base. We have Alka-Seltzer, which surprises me. I actually would have told you I thought maybe it would be acidic, but it actually also remained the same purple as the red cabbage juice indicator. So that's something you can research. Find out why is Alka-Seltzer pH neutral. We have our lemon lime soda, which is this gorgeous fuchsia color, which actually makes sense when you think about it because lemon lime soda is flavored with citric acid like you would get from a lemon or a lime, so which means it's slightly acidic. Then you have 2 really strong acids, the lemon juice and the vinegar. And then we also have baking powder, which has a natural pH of about 8, which has stayed this kind of cool blue color, which means it's not quite green, not quite purple, but tending towards the basic end of the spectrum. If you want, you can arrange yours in a rainbow, measure write down the pH of each one, and I want to see some of those pictures so I know that you did the experiment. So if you're going to do any of these at-home science experiments, it's important to remember that STEM learning at home is different than STEM learning at school. Obviously, at school you have specialized tools and equipment, and at home you have to make do with what you have. But this is a great example of a science experiment in the everyday. You know, if you like baking, if you're going to be baking your own bread, it's a great time to talk to your kids about chemistry. If you're going to be outside doing gardening, it's a fantastic opportunity to talk to your students about the life cycle of plants and how to care for our earth. Just give yourself a little bit of grace. This is an unusual time and we're all doing the absolute best we can. If you'd like some more at-home science tips, you can visit us online at learningundefeated.org.